My name is Genevieve Langdon. I'm a professor at the University of Cape Town. I work in the Department of Mechanical Engineering, where I'm also one of the deputy heads. And you? My work is on looking at the effects of explosions on materials and structures, and particularly lightweight materials such as composite materials and sandwich panels, which are the things, say for example, your surfboard might be made of, and trying to see how they respond to explosions to try and make the world a safer place. BISRU is an accredited research unit at the University of Cape Town. We're based in the Department of Mechanical Engineering. BISRU is an acronym. It stands for Blast, Impact, Survivability Research Unit. So we look at any situation where you get some sort of extreme loading event. So that could mean a high pressure, a high temperature, a short duration loading and impact. And the classic example that we look at a lot in BISRU is an explosion.
There's two people who are licensed to get to make charges here. It's myself, Professor Langdon and Professor Nurick. As much as we love blasting, we want to get as many students in. It's a bit difficult, because of the time we've got. So we try to fit in about 5 to 6 undergraduate students on top postgraduate students and visiting students who comes in. So part of my job here is to set up the charge, one of them, and also help them. Like sometimes if they're too slow to work, I'll get my hands dirty and help them to bolt some nitty-gritty work.
My name is Canal, and my project was about optimizing circular plates. I did some simulation to find an optimum shape that will create less deflection for the plates, and right now we're blasting them to find out the deflections, and then we're going to compare them to just a normal standard plate.
Obviously for health and safety reasons we don't allow access to explosives to just anybody that walks through the door. So myself and Dr. Chung are the only two that are licensed. We're the only ones that handle the explosives and the detonators. Explosives are dangerous for a number of reasons. One of the things that they put in an explosive is a tracer, which makes it poisonous to stop terrorists eating it and trying to carry it out of the country undetected, for example. So you must handle all the explosives wearing gloves so that you don't transfer that into your hands and then eat something. And then the other thing is explosions create a lot of noise. So aside from the physical risk of injury should it go off prematurely when you're holding it or whatever, once that's all dealt with and everything's set up properly, everybody must be wearing ear protection because that's the next risk, is noise. Then there's a siren that we set off which just lets everybody know outside of the immediate area that there is about to be a blast. UCT isn't being hit by bombs from outside or terrorists. This is a plastic explosive. It looks just like Play-Doh, except it's an adult version. This has got RGX in it, which is a very powerful explosive, and then we would mould that into the precise shape that we want. And then we would mount that on something, which we might want to detonate. And then we would insert the detonator into this, which works via an electric charge. And inside here is a more sensitive explosive that will detonate, and then that would set off the main charge. So they would be connected like this. And that's how we do our experiments, looking at different shapes, different sizes of explosive, putting them in different places relative to the structure or the target. And then looking at the response, and then trying to use instrumentation to understand what happened during the explosion, the loading, the response to the structure, and then using that information to make better decisions about blast protection. It really is the most amazing thing that I can get paid for really exploring an interest. Every day is different, which is what's really great about it. I'm very lucky in that my husband put his career on hold when we had the children, and he committed to staying at home so that I could carry on doing research. It just takes a lot of effort to try and manage your time so that I can be home when the boys are around. Going to work's a joy, it's not a chore. I can work on problems that are of interest to me and hopefully to the rest of the world. And I get to influence students, teach them something, they grow, they learn, they develop, and I get a kick out of that. And then I can come home energised when I've achieved something, and that's exciting, and then I can be with my family and enjoy them as well. So I'm actually very fortunate.